In this video, we will learn how to evaluate inverse trigonometric functions. What's an inverse function? It's a function which is obtained by switching the input and output of a given function. So for example, you know that sine of pi over 6 is equal to 1 over 2. Now what does that mean for the sine function? Sine inverse function. Sine inverse of what is equal to 1? Well, 1/2 is the output of the sine if you input pi over 6 into the function sine, right? So for the sine inverse function, you have to say sine inverse of 1/2, which was the output of the sine function, is now equal to pi over 6, which is the input of the sine function. Now, since so many people are confused with the difference between an inverse function and the reciprocal function, let me state the difference between the two. So here's the sine inverse of x, which is the inverse function of the sine x, and here's another function which is the reciprocal of the sine function. This negative one creates the multiplicative inverse of the sine function, whereas this negative one creates the inverse function of the sine function. And inverse functions and multiplicative inverses are completely different things. Multiplicative inverse is another name for reciprocals. And reciprocal of a sine function is called cosecant of x. And that is completely different from sine inverse of x. So for example, if you have sine pi over 6 equal to 1/2, in terms of the cosecant x, it means that cosecant of pi over 6 is 1 over sine of pi over 6, and that's 1 over 1 over 2, which means it's the reciprocal of 1/2, which is equal to 2. And as you can see, the way that cosecant value corresponds to the sine function is different from the way that the sine inverse function corresponds to the sine function. There are, of course, other reciprocal functions. Cosine x to the negative 1 is called secant of x, and tangent of x, reciprocal of the tangent x, is called the cotangent of x. And all these functions have, all the trigonometric functions, including even these reciprocal functions, have inverses. So, you know, the 6 trig functions, sine, cosine, tangent, cosecant, this is the reciprocal of sine. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. All these have reciprocal, the inverse functions. Their function inverses all exist. Okay. Now, one thing I want to add to this is some people prefer to call sine inverse of x as arc sine of x, okay, and everything also. Instead of saying inverse cotangent function, people will say arc cotangent of x. Now both of these are in use, so you have to know that they are the same thing. Whenever you're being asked to find arc cotangent of 1, for example, you should know that it's asking for a cotangent inverse of 1. Why are there these two different names? The reason for this is because sine inverse of x is somewhat deceptive. This is not really the inverse function of the sine function, but it's a inverse function of some restricted version of the sine x. So I'm going to explain that in the next slide as we find the value of the sine inverse. But that's why there are two different names. Okay, let's think about how to evaluate sine function, since we now know that it's the inverse function. So suppose you're given this question: evaluate sine inverse of square root of 2 over 2. Well, the first step of answering this would be step 1, set it equal to x. And then think about what it means for the original sine function. See, this is the input and that's the output, but since this is the inverse function, for the original sine function, they must have been switched. Sine of x must have been square root of 2 over 2. So what we're getting is a trigonometric equation which you have to solve for x. How do you solve for x? So that will be step 2. You would solve this equation for sine of x. First, draw the sine curve. And when you draw the sine curve, try to follow the methods I'm using. So first, mark 2 pi. Half of 2 pi is pi. Half of pi is pi divided by 2. And then the midpoint between pi and 2 pi is 3 pi over 2. And for these points, you should know the value of the sine. It goes like 0, 1, 0, negative 1, 0. Okay. Well, you don't really have to memorize it. You can just memorize this shape. It goes 0 up, 0 down, 0. Okay. So doing this, you can always draw the sine curve. And then you're going to figure out at what angle the sine x will become square root of 2 over 2. Those who watched my previous video will know that the square root of 2 over 2 is called the medium size. So medium size is like right at the middle. So this is 90 degrees and 0 degrees. Right at the middle you have the 45 degrees, or half of pi over 2 is pi over 4. And right between 90 degrees to 180 degrees, the average of 90 and 180 is 135. And in terms of radians, that's 3 pi over 4. Now, so we figured out the angle that creates square root of 2 over 2, but we actually realized that we now have to choose between the two possible numbers. Which one should I choose? Pi over 4 or 3 pi over 4? Actually, this is the reason why you can't define the inverse function of the sine function. If you try to define the inverse function of the sine function, you not only get one solution, but you get many solutions. You get this solution, that solution, and if you remember that sine functions are periodic functions, so it extends infinitely many times to the right and also infinitely many times to the left. So there are many other places where sine does give you square root of 2 over 2. In pre-calculus, this is the way you were taught. You were taught that if you have a graph which fails the horizontal line test, see, this fails the horizontal line test because at square root of 2 over 2, if you draw this horizontal line, you have more than one solution. So it fails the horizontal line test. If it fails the horizontal line test, you say that the function's inverse cannot be defined. That's why sine inverse is not really the inverse function of the sine function. The way mathematicians decided to get around this problem was, one solution would be to never talk about the sine inverse function at all. However, when people tried to use trigonometric functions, they realized that this inverse sine function was very important. So instead of opting to not define it at all, they did this. First, they looked at the sine graph, which is this. That's a sine graph. This is the sine graph from 0 to 2 pi, which is the same as this. And then if you copy this over to this side, you get this sine graph. Here's pi, here's negative pi. Now, they looked at this graph and decided to take only the portion from negative pi over 2 to pi over 2, from here to here. And in this interval, the only angle that will produce square root of 2 over 2 is now just exactly pi over 4. That's the only solution, right? So therefore, we can with this restricted domain, we can happily say x is equal to pi over 4, and therefore sine inverse of radical 2 over 2 is pi over 4. Okay, that's how you evaluate an inverse function. Step 1, you introduce an x, make it as turn that into an equation. To solve the equation, you draw the sine graph. However, instead of drawing from 0 to 2 pi, try to draw it from negative pi over 2 to pi over 2. Okay, maybe with one more example, you might be more comfortable with finding the sine inverse. Okay, so sine inverse of x again. Let's try sine inverse of negative radical 3 over 2. We want to find the value of sine inverse. What is it? Step 1, introduce an x so that it turns into sine of x equal to negative radical 3 over 2. Now draw the sine graph from negative pi over 2 to negative pi over 2 to pi over 2. And because sine graph goes like that, if you extend it this way, the graph would be like this. Okay. And this value, I like to call this as large because it has 3. So 1, 2, 3. 1, 2, 3 over 2 over 2 over 2. I like to call it small, medium, large. And since radical 3 over 2 is the large value among the 3 special angle values, the large appears here. Let me draw with another color. So this is a large one, and that's another large one. So these are the large value which creates square root of 3 over 2. However, we're looking for the one that creates negative 1, so this must be it. So this one, which is negative 60 degrees, or in terms of radians, negative pi over 3, is what we're looking for, and therefore sine inverse of radical 3 over 2 with minus is negative pi over 3. Now, what could be really helpful is the following fact, that sine inverse of negative of some value a is same as negative of sine inverse of a. Okay, that's also true for tangent inverse of negative of a, because it also gives you negative of tangent inverse of a. These two formulas hold because their original functions also have the same property. Sine of negative a is equal to negative sine a, and also tangent of negative a is negative tangent of a. However, you have to be careful with the cosine function, because for cosine functions, it is not true that cosine of negative a is equal to negative of cosine of a. Instead, for cosine functions, cosine of negative a is equal to cosine of a. All right, maybe it's time for us to move to the cosine function, because as I draw the cosine function, you might be able to understand why cosine inverse is like this. So let's draw the cosine function graph first. Cosine function, start from 2 pi, half of 2 pi is pi, half of pi is pi over 2, and pi and 2 pi, 3 pi over 2. Okay, and the cosine graph starts from 1, it goes 1, 0, negative 1, 0, and up. That's the cosine function. And it extends infinitely many times to the right and also to the left by copy and paste. So you just Control C this part and Control V, Control V, Control V, and you get these graphs. That's the graph of cosine. And if you just look at this part right here, do you see that the cosine is symmetric with respect to the y-axis? So that if you evaluate the cosine at negative a, which is this value, that's same as the value of the cosine at a. So that's why cosine of negative a is equal to cosine of a. This is different from the sine case. Sine case, you have this, and if you evaluate at negative a, that's negative of the value of the function at a. So this will be the sine function. This will be the sine x. But cosine, it just consumes away the negative. And because of that, the cosine inverse of negative a has a very strange formula. So I'm going to write down the formula for it, but maybe it's not that important because it's hard to remember. It's cosine inverse of negative a is pi minus cosine of a. Okay, so if you want to use this formula, you may, but I don't think it's that useful. Okay, so to reiterate what I just said before, if you have sine inverse of negative a, you can just take the sine inverse of a and put a minus in front, and same thing for the tangent inverse. However, for the cosine inverse, you get something rather strange, and just remember that you can't do the other do cosine inverse like the sine inverse or tangent inverse. So if you remember that will be good enough. Okay. Now let me show you how to evaluate the cosine inverse function. Now if you look at the cosine inverse function, if you just take the portion from negative pi over 2 to pi over 2, it's going to fail the horizontal line test. So to define the cosine inverse, taking the interval from negative pi over 2 to pi over 2 is not very good. To have the inverse function, you have to restrict the cosine x to the domain 0 to pi. Okay, and here, if you only have this portion of the cosine function, then it clearly passes the horizontal line test, and you have no problem in defining the inverse function. So you have to remember that for the cosine x, always the answer should be limited to angles between 0 to pi, or in degrees it's 0 to 180 degrees. Okay, so let's put a question here. It's very similar to sine inverse, so I'll just do one problem. Let's say cosine inverse of negative 1/2. Okay, step 1, what do? You set it equal to x, so that if you rewrite it in terms of the cosine, the input and output get switched, so you have cosine of x equal to negative 1/2. And therefore therefore you have an equation for cosine of x, which should be solved using the graph from 0 to pi. Goes like that. And over here, this negative 1/2 is the negative small value. So out of the 3 special values of cosine things, cosine or sine, this is the smallest one. So since this is 90 degrees or pi over 2, you have to go 30 degrees. This is 30, 45, 60. So 30 degrees after 90 degrees, that's 120 degrees. 120 degrees in terms of radians is twice of 60 degrees, and 60 degrees is pi over 3, so it's 2 times pi over 3. So this angle here is 2 pi over 3. We found it, therefore our final answer is that cosine inverse of negative 1/2 is equal to 2 pi over 3. Okay. Now finally, let's try to do a question on the tangent. The graph of the tangent looks like this. Graph of the tangent has 2 vertical asymptotes, actually infinitely many vertical asymptotes, but it has vertical asymptotes at negative pi over 2 and pi over 2. And the graph itself looks rather like y equal to x cubed, but it's actually in detail it's a lot different. This is the tangent x graph. It's again a periodic function, so this thing repeats itself infinitely many times, but at this interval, this tangent function is 1 to 1. So whenever we talk about the tangent inverse, we will limit the tangent interval to be on the interval negative pi over 2 to pi over 2. So another way to say it is that tangent inverse of x is the inverse of tangent x function restricted to the interval negative pi over 2 to pi over 2. That's what tangent inverse of x is. All these inverse functions are really inverse functions of the restricted version of these trig functions. Okay. All right. So here's an example. Find the tangent inverse of square root of 3. Okay. Step 1, set it equal to x, and then rewrite it as tangent of x equal to square root of 3. Now, the value of the tangent is either the smallest is 1 over square root of 3, and at 45 degrees it's 1, and square root of 3 is the largest value. These two are reciprocal of each other. In most cases, this value is instead written as square root of 3 over 3. You get these two are same numbers because if you rationalize the denominator of 1 over square root of 3, you get this number. Okay. All right. So you have tangent of x equal to square root of 3. On this graph, where does that happen? Well, small, medium, large. Right. Yeah. Where the smallest is 1 over radical 3, medium size is 1, and radical 3 is the largest one, and therefore this is the angle where you get square root of 3. And again, these are at the special angle, so it's 30, 45, 60. So this is 60 degrees, which in radians it's pi over 3. Therefore, x equal to pi over 3, and you end up with tangent inverse of radical 3 equal to pi over 3. That's how you get the tangent inverse function. Okay, to evaluate the inverse function of the reciprocal functions is also done in a similar manner. Yeah, let me just do that one more, just to show you how to do the inverse function of the reciprocal function. So, for example, let's say you had secant of inverse of 2. Okay, or sometimes you could be asked, what is the arc secant of 2? How would you find this? Well, first set it equal to x, and then rewrite it as secant of x equal to 2. And then think about what secant of x is. That's the reciprocal function for the cosine. Right. So in terms of the cosine function, you're really looking at the reciprocal of this right side, which is 1 over 2. Okay, so here's the reciprocal. And then, if you look at the graph of the cosine from 0 to pi, you only have, well, large, medium, small. This is a small value. So this happens at x equal to pi over 3. And therefore, you can say that secant inverse of 2 is pi over 3. Okay, so finding the inverse functions of the reciprocal trig functions just requires this one more step where after you take the trigonometric equation, you take the reciprocal of both sides. If you take the reciprocal of the secant, you get the cosine. Reciprocal of 2, you get 1/2. And you have to solve this instead. So that's just one extra step, and I believe you'll be able to figure out how to do the cosecant inverse and cotangent inverse in a similar manner. Thank you.